Right, I'm a bit late getting started today. Oops. About 15 minutes late. Wonderful. All right, so goodbye, top 100 rank. um, wow, so these are getting tough. Yesterday's 19, that took me 4.5 hours of coding, pretty much in total, in 2 different sessions. So see what we have today. Grove Positioning System, GPS. Wonderful. Oh, looks short, so that means it's easy, right? It's finally time to meet back up with the elves. When you try to contact them, however, you get no reply. Perhaps you're out of range? So I'm trying to pour my coffee while I don't want to scold myself. You know they're headed to the grove where the starfruit grows. Oh yeah. Oh yeah, that old thing. The whole point of this trip was to find the starfruits. And then at the end, it's gonna be like, oh, the true stars were the stars you collected along the way. So if you could figure out where that is, you should be able to meet back up with them. Fortunately, your handheld device is a file that contains the grove's coordinates. Fortunately, the file is encrypted, just in case the device were to fall into the wrong hands. Maybe you can decrypt it. So I don't know the encryption key. Well, the point of encrypting is that you're not supposed to be able to break it. When you were still back at the camp, you overheard some elves talking about coordinate file encryption. The main operation involved in decrypting is called mixing. The encrypted file is a list of numbers. To mix the file, move each number forward or backward in the file. A number of positions equal to the value of the number being moved. The list is circular. So moving a number off one end of the list wraps back around to the other end as if the ends were connected, okay? Example, to move the 1 in a sequence, like so. The 1 moves 1 position forward. Oh, you move it according to its number. That's interesting. Okay. The numbers should be moved in the order they originally appear. Huh? Okay. Consider this encrypted file. Mixing this file proceeds as follows. Okay, so you pick 1, move it forward, pick 2, move it forward twice, pick -3, move it... Okay, got it. Then the grove coordinates can be found by looking at the 1000th, 2000th, and 3000th numbers after the value 0. Wrapping around the list as necessary. In the above example, the 1000th number to 0 is 4, 2000th is -3, 3000th is 2, okay. Mix your encrypted file. Oh, so we're not trying to decrypt, we're just re-encrypting it, basically. Okay, fine. Just get my coffee sorted. Alright, so this is the... Oh, it's one long. Okay. Man, yesterday I wrote one heck of a program. Okay, so where's the... We'll take out the... Just run that. Okay, so we need... So it's kind of inefficient to be cutting up and moving stuff around in this list, but we can try doing it anyway because I think the numbers are small enough. Okay, so okay, let's make a copy of this. Order equals data, because I need something to remember what the original order looked like. So let's do for x in order. All right, so we find, let's say I equals data.index x. Now, I don't really want to do this because we could just keep track of where they are at all times. But we could do that by creating a custom class at some point, but for now. Right, so I is the index. So we want to move it hang on. So the new I will be I plus x percent n. So basically we want to I'm just thinking about. Well, we can delete data I. Now take it out, and we want to put it in. Now the problem is, if we've taken that out, that might now mess up the index. Right. If new I is greater, strictly greater than what the old position, then we want to just subtract 1, because we're now missing that piece, so the indices are kind of messed up. It's probably a cleaner way of doing this using swaps or something, but insert, how does this work? Alright, does that actually terminate? Yeah, okay. Pretty quickly. Then what? We want the... So now it's all jumbled up, okay. Now we print up to the value 0, so I equals data dot... Hello DIJ. Started about 15 minutes late today. Okay, part 1 seems easy enough. Data dot index 0. I'll go and... The key works. Oh, nice. Okay. What was it? The game again? Tyranny. I think Tyranny is one of those games that's been sitting in my Steam inventory forever. So I really should play it just because I have it. I can't remember if I bought it or I got it for free, or most likely I got it in a bundle. It looks like it's a good game. So yeah. So now we want A equals I plus 1000. So N print, okay, B equals A plus 2000. So we're doing some sort of encryption, and I think I'm about to solve part 1, so I can go and describe it again after I've done that. Alright, and then we just print ABC, and that should be it. That's quick. Yeah, I regret not starting on time. 917. Oh, we need to print A plus B plus C. 4751. Damn it, it's wrong though. Alright. Slow down a bit. Wasn't that your thing? What was my thing? encryption. I know a bit about encryption, but it's one of those topics I find is more... I mean, okay, it involves a good amount of mathematics, but a lot of it is just knowledge of all the various policies and algorithms that people use, and it changes all the time. Well, real life encryption does. This is some sort of custom encryption, so it's really mathematics. So yeah, this is probably my strength. Although it seems to be more about data structures than it is about maths. Here, we'll see. Alright, what have I done wrong? As always, let's go to the example. Alright, so yeah, let's describe the problem. So basically, we have a list of numbers. So we put them in a list. We take the first number from the original list. We find it and we move it by the amount. We move it one position. So we take the raw amount that it represents and we move it forward that many spots. So we take one and we move it one. Then we take the next number from the list, 2. It's there, and we move that 2 positions, 1, 2, and so on. We go through the entire list once doing that. Then we end up with a new list, and we take the 1000th, 2000th, and 3000th numbers after the value 0. So it wraps around. Oh, I think I know what might be the bug. I was taking the 1000th and then the 2000th after that. This should be from I. From 0, from wherever 0 is. Not from the last number I calculated, 5751. Damn it, that's wrong as well. Okay, let's use the test example then. But that was a bug anyway. Also, just in case... I don't want to be getting empty lines. I don't think that'll turn into an int anyway. But not split, strip. Okay. Oops, thank you for alerting me. I always forget. I mean, I was thinking I might create a shortcut for switching between them, but at some point I'll accidentally hit the shortcut and switch away. So it's... Alright, so I've got the new input. Let's run this. 12. Should be 3. Okay. Let's print each. Okay, at least this is quite visual. I can just print the row each time I've done something and see how it lines up with what they've done. So we start with that, and I don't think I've even moved number 1. That's not right, is it? Yeah, so it's hang on. Yes, that's the first time I print. For X in order, data, we find where x is. The new... Okay, and I represents the location. So let's print I and new I. Print I, new I. 0, 1. So the 1 is at 0, correct? The new I should be at 1. Alright, so then we delete 1 out of this, so we end up with 2, 3, minus 3. Now, because new I was 1 index higher, I'm subtracting 1 to compensate? No, hang on. That's not right. I should... Hang on. Now this is confusing me. So where would we want this to end up? In position index 1, i.e... Oh, I see. So we actually want to add 1 to this. So it's just because of the way the Python indexing works. So we're saying 1 is at position 0. We now want to insert it at position 1. But what we really mean is displacing 2. So if we can't just insert it at 1, we have to push it 1 forward in order to push the 2 back. Is that gonna work? Right. Hang on, let's try that. We get 3, so it looks like that is indeed... But is that logic sound? Because I'm now worried about that. Yeah. Could try that anyway. Five, 7, 5, 1. Wait, what did I have before? That's what I had before. What? Damn it. That was a bug anyway. This is not hard, I'm just messed up the indices. Alright, let's think this index thing over again. So maybe this subtracting 1 is an issue as well. So we find where the index is. We add the amount to where we want it to be. We add 1 because we want it to be kind of pushing the current element to the left. Basically, we want to be swapping with items as we're going along, but that would just be a bit slow. So then we delete it from the list. Now the problem is when we delete it, now this kind of messes up the indices slightly. So we compensate by saying if we are higher, if the index is higher than that, we now subtract 1 to compensate. If it was lower, that's fine. Deleting the data won't mess up those indices back there. And now we insert into the new position X. I don't know. Alright, well, let's go back to the example then. We got the right answer, but let's just check it line by line. So a couple of things I need to do. I might need to take a 5-minute break. Send a quick email as well. See if I can get part 1 done. Alright, so I'm looking at the browser between this. So 1, 2, minus 3, 3, 2, 0, 4. 2 and 1 basically get swapped. That's correct. Then 1, minus 3, 2, 3, 2, minus 2, 4. Yeah. Yeah, no, I need to go do those things now. Alright, I'm gonna just go for a few minutes. I can finally use my Be Right Back screen. Where is it? Alright. Let's continue this. So, what on earth went wrong? So it looks like this example is correct. No, it isn't. It isn't. The final state should have 1, 2, minus 3, 4. Alright. So where did it go wrong? So 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, minus 3. So this one's 1, 2, 3, 2, minus 3. 1, 2, 3, minus 2, minus 3, 0, 4. That's correct. And then when we go to the next one, 3 moves between. So we need to move 3 forward. So it goes 1, 2, 3. So 3 ends up in the correct place. So how do we end up with minus? Wait. No. Minus 3 is still in the wrong place there. We have to go back. Damn it. I can't. Alright, let me minimize this window so I can see them side by side. Alright. So we've got 1, 2, that's correct. Then 2, 1, minus 3, 3, minus 2 are 4, correct. Then 1, minus 3, 2, 3, minus 2 are 4. So the first ones are correct. Then we go 1, 2, 3, minus 2. 1, 2, 3, minus... Alright, so it's the problem is from this line, we then want to move two. We want to move two spaces forward. 1, 2. How do we end up with that? Okay, something's gone horribly wrong there. No. We want to move... Yeah. We want to move minus 3 back 3 spaces. Okay. It seems it doesn't move back far enough. So minus 3, the new position, should be 5. Oh, so if it's positive, okay, this is a weird way I'm doing this. So, if we're going forwards, we have to add 1 here. If we're going backwards, we have to minus 1 because you're going the other way. Plus, so this, okay, this is a bit hacky. So, 1 if x greater or equal to 0, else minus 1. Okay, so do we actually end up with the... No, now we get 9. What? One, two, three. Okay, let me just check these again. 1, minus 3, 2, 3, minus 2 of 4, 1, 2, 3, minus... Alright, there's another problem here. 1, minus 3, 2, 3, minus 2 of 4. So this one, going to the next one, minus 3 moves back 3. Okay, it's this thing again. So we go 1, 2, 3. Oh, okay. That should be 0, not minus 1. You don't compensate at all if it's negative. Okay, again. Still the wrong answer. If you're going back 1, then you don't need to add an extra shift. That's correct, right? So we get as far as -3. So now we're handling -3. We move it back. Okay, that's correct now. That line is correct. Alright, so... And then we move 3. We end up with 1, 2, -2, -3, 0, 3, 4, correct. Then that's correct. -2 moves back 2. What? Why does it roll over in the example? -2. So -2 should go back 2. But in the example, they move it back 3. Have I misunderstood then how this rolling thing works? Alright, let's have a look. Okay, I don't understand this. Let's have a look at the browser. So they're saying to move 1. So in this sequence, if you move 1, you move it 1 forward. Hello, Quantum. They don't move it back 3, but the rule around where elements go when they move between the beginning and the end of the list is weird. Okay, so moving forward, they move 1 to there, that's fine. Move the -2 in a sequence like this. The -2 moves 2 positions backwards, wrapping around. Oh? You'd think -2 at index 2 would move to 0, but it moves to the end of the list. What? So, that's so weird. So what is the overall rule then? So if it's... So if we ever wrap back past 0, we just have to move 1 more step, basically. Oh, it's by amount of movement. I wasn't thinking about amount of movement, but that actually sort of makes sense. Wait, so... -2... Actually, no, that doesn't make sense to me. It's still 2 hops to arrive in position 0, but I sort of... Wait, okay, fine. I'm trying to see how to make that rule rigorous. Moving a number off one end of the list wraps back around to the other end as if the ends were connected. Basically, elements can't move to position 0. If they do, they just go to the end instead. It's so weird. You can never end up with something going to position 0. Would it be the same the other end as well? I think they've really made this nonsensical. Hang on, so this example I was looking at here was fine. I didn't have any problem with this. Swap with 4. And then swap with 9. Yeah, this one's fine. This one's fine. Wait, didn't I have a problem with this example? No. Okay, now that I look at it, I don't see any issue with this. This is in line with what I'm doing. 1. 2. You had a problem with -2 in the example. What problems did I have? I'm now so confused. Oh yeah, no. I'm talking about the what I'm looking at the browser. So I'm fine with the browser, that example there in the browser. Okay, fine. So going back to this, what did I say? Right, I said -2, and I want to move it back 2 positions. So I've moved it back 2 positions. So what you're saying is it should then just go to the end. So in the... It doesn't actually matter because of how the final score is calculated. Yeah. I suppose it shouldn't matter. I am getting a wrong answer for this though, so we need somewhere there's a problem. Okay, so -2 goes back to... So let's say I'm correct order. It's kind of weird now. 2 minus... Okay, so it's 1. I can think of it as 1, 2, -3, 0, 3, 4. -2. Okay, so that's correct. So... Okay, what has happened here? That's no change. Hello, a divorce fork. Calculated relative to the new position of the 0 value. I think I am using the new position. I'm refinding indexing where 0 is. Okay, something's gone wrong here because there's no change. Or maybe there is not meant to be any change. Let's see. 0 does not move. Okay, 0 does not move. So that's correct. So that one's correct. And then from here, 4 moves between... So moving 4 now. Ah, there's a problem when I'm going forwards off the end of the list, because if I move 1 space forward to position 0, I haven't actually swapped any places. Man. How did I make such a mess of this indexing thing? It shouldn't be this hard. So if I'm going forwards off the end of the list, I have to... But if I'm moving 4 forwards, I'm counting switching to position 0 as one movement forwards. Oh no, I'm not. I'm not. I've compensated for that. Have I? So 4 should end up 1, 2, 3. It should end up where -3 is. That doesn't look right. So yeah, I don't think this is correct. One, 2, -3. So this is correct so far. Now we're moving 4 spaces to the right, so it should go... One, 2, 3, 4. So what I did was actually correct, okay. 1, 2, -3, 0, 3, 4, -2. And then I'm just printing that again, okay. So how do I get 9? Thousandth number. Oh, that's stupid. I didn't actually extract the data from those positions. I just literally just added the indices together. So all my confusion arose from me just by coincidence getting the correct answer for the test case. Doing that. That was dumb. There we go. Alright, finally. Come on. 10,702. Still wrong. Damn it. So if I'm going forward, I find the new position it should be in. And if I'm going forward, I add 1 because I want it to be inserted to the right of whatever's already there, thus pushing that thing back. Okay. I delete the old position. And then if the new position is strictly to the right of the old position, I take away 1 to compensate. There's got to be a better way of doing this. Maybe I should use a linked list or something. I need to get another copy. This is... Oh, I've got a bit left. This is the easy. This is part one. This should have been easy. Just moving things around in a list. Okay. Should I just do this as a series of swaps then? Let's try and do it in line with how they're doing it in examples. So you say part one should be easy. No, I'm saying it should be easy based on this description. This is something I could have done when I first started learning Python. It's literally just moving things between indices. This is one of the first things you learn in Python: slicing and indices in a list. There's nothing technical that I could be getting wrong here. Alright, I want to try and just make my example look exactly like this, just that helps, I guess. So the problem, so when they moved -2 back, I don't like the way they've done that. I don't understand why -2 jumps to the end, so okay, I won't do that. But I think swaps is a good idea, maybe. So let's say I is where it is now. The new I would be I plus the amount. No, we don't want to do that. We want to say for in range of their duplicate values in the real input. Oh, that's a good point, isn't it? I don't think they would, based on. Oh, yeah, no, they could be. But okay, we'll check. They did say the V0. And let me read the description. After the value 0. Suppose there could be duplicates. Alright. Print n length of set of n. So, oops, set of data. Damn, there are a lot of duplicates. So one way I could just fix this would be to well, that is sneaky, putting lots of duplicates in there. See, the fact that they reference the value 0, I mean, there's probably a unique 0, but the fact that they reference the 0, it's kind of half implies that there is a uniqueness of numbers here, but okay, we shouldn't have assumed that. Yeah, thanks for spotting that, Quantum. You're lucky your approach didn't run to that. So were you like keeping pointers to where they were? So if I were to just... So I could just attach... Oh man, so... Just zip the data with the original indices. Yeah, that's what I'm thinking to do. I'll just attach them to... So for line in f.readlines... Okay, let's do this for I line in enumerate f.readlines data.append. We'll put the index as a tuple, the index and the integer itself. So this is all going to break now. That's what it looks like. All right. It's unique now. So for ID num x in order, I equals data.index, so we need to index the ID num with the x value. Okay, new I equals I plus x. This is all, I guess, correct. Data.index. Okay, and then we need to find 0. So I guess there's a unique 0. So or I in range n if or if data I1 equals 0, break. So now we take that plus 1000 plus, and then we want to extract the second parameter. 4883. Wasn't 5000 too low? No, it was too, maybe it was too high. So 10,000 was too high anyway. We should have known. 4883. Still not really confident. Nope, it's wrong. It didn't tell me whether it's high or low this time. 10,000 was too high. You could adapt the small example to have a duplicate. Well, let's check it's still working on the original example. So it's -2, 1, 2, -3. -2, 1, 2, -3. Or 0, 3. Yeah, that's correct. Oh dear. I still think this indice thing is dodgy. So I think I might just do it as a series of swaps. I shouldn't have to resort to doing that. I should be able to identify the location it goes to without making a mistake. Like, if you take the test case and replace the -3 with another 3, you can easily check it against the example. Could try that. -3 with a 3. But, I mean, it would diverge from the example, won't it? Yeah, we would expect it to diverge. Unless... Yeah. It could be that I might be missing one of these. Okay, let's have a look at this again. Index that pair. That's the only time we use the ID num and inserting a new one as well. So when it doesn't move, it will be I +1. It's fine, I guess. And subtracting 1 is safe as long as we know it's strictly greater than 0, and it is. It wouldn't diverge because 3 is congruent to -3 mod 6. So you think I should get the same result? Okay. But there's 7 items, not 6. So if I get 9, that's, you can check my hand where with -3 move, it was a 3 as opposed to a -3. Yeah, I mean, I can test this. So it would diverge at the point where, okay, let's just where we do the -3 moves, so it's so that should be as before, and now we're moving the 3, which is we want the second 3 to move. On the last line, -3 would move between 3 and -2, and if it was a 3, it would do that too. Okay. I mean, it looks... okay, so where was I? Here, so moving the second 3. No, we should be moving the first one. Hang on, so we changed the first one, yeah, okay, so... Seems like correct. And then the next 3 should be moved. Hang on, is that correct? So this 3 should be moved forward. 1, 2, 3. Yeah, it comes after 5.0. Yeah. So that seems correct. I think the -1 comes from the fact that if an item moves past all other items, it's back where it started. What -1 are you referring to? The fact that it's mod 6 and not mod 7. Oh, okay. So I should be using mod 6? I'm so confused. I delete the item, then use mod of length. Okay, I'm a bit lost. So are you saying that somewhere I should be using mod n-1 instead of n, like here, for example? The only time I use... I mean, I could rewrite this to not use mod at all. Oh! Did I not switch back? Whoops. So, like, the only times I use mod are at the end for extracting the answers, and here when I doing the index. The ending ones are correct. So you think it should actually be n-1 for this? So if we are 1 from the end, and I want to move forward 1, this would tell us to move to so we'd get to the end index. Yeah, I think I should just rewrite this. This is I can't make sense of this. So let's just do the swaps way. That way we know we're getting the movement. Correct. So we found where it is. Now for so if it's 0, we hang on. So yeah, for range x, absolute value of x, we perform a swap. So we find swap I equals I plus, and then we want just do this to get the sign, because it should never be 0 in this loop. And then we want to no, yeah, okay, so that's adding 1 or -1. So the only times we would ever need to do anything is, okay, so if we were at the end, we would be -1 mod. No, if we were 1 from the end, we would be -1 mod the number. So adding 1 would bring us to 0 mod the number. hang on. No, we're trying to find the item to swap it with. So yeah, we do need to percent n because that item is already there in the list. Yeah, that's right. Okay. And then data swap I equals data swap I data I. Get rid of this. No deleting or weird stuff. It's just that, right? See, we get a different answer for that example where we added another 3. That's interesting. So maybe you need to advance I to swap I after each swap. Oh yeah. So yeah, that was a bug. Okay, we're back to 9. So 9 is probably correct because I did sort of check it by eye, not all the way, but alright. So put that back. Was it like that? 3. Alright, let's just try. Yeah, no, it's fine. Like if it's debugging the way I've done it, I'm totally fine with backseating. Alright, let's try this. Oh, don't print. Now it's taking a long time. Four, 5, 7, 8. But what did I get before? 4, 8, 8, 3. And it didn't tell me if I was too high or what. I mean, I trust this more. Well, there's no reason not to try this. Let's try it then. Okay, we're correct. So basically the index thing was just a mess. Damn. How long did that take me? 1.5 hours, and it should have taken me like... I mean, I had this written up within 10 minutes. It was just my indexing that was off if I had done this from the beginning. Alright. Oh dear. Part 2. Grove coordinate values seem nonsensical. While you ponder the mysteries of ELF encryption, you suddenly remember the rest of the decryption routine you overheard back at camp. First, you need to apply the decryption key. Multiply each number by the decryption key before you begin. This will produce the actual list of numbers to mix. Second, you need to mix the list of numbers 10 times. The order in which the numbers are mixed does not change during mixing. The numbers are still moved. Okay. So if -3 appears fourth in the original list of numbers to mix, -3 will be the fourth number to move during each round of mixing. I feel like it's not adding complexity aside from the fact that we're doing this 10 times. Yeah, it's not actually adding computational complexity, so we should be able to get this. If I don't mess things up. Right, so key. Alright, that's part 1. Let's do part 2. Key equals. So we want data is gotta remember to do that. Data equals, let's remove all that stuff. Right, data equals order. Again, a fresh copy of order. So we can find things by so when I'm doing hang on, so what was the answer we got there? Four, 5, 7, 8. So let's just change this index thing to actually find the ID num. For I in range, because I don't actually want to index it that way, so for I in range n if data I 0 is ID num break. That should always, let's just check that we still get much slower, I guess, because every swap, well no, swap does swap in place, so, but yeah, I guess it's doing it. Well, inserting and putting in a list is still a linear operation. It should actually be slower than doing the swaps, because you then have to reshift possibly the whole list in memory twice, once for deleting and once for inserting. So why is it so much slower? Alright, so 4, 5, 7, 8, that's still the answer. Okay, so we'll do it that way. Alright, so okay, so first we need to alright, so let's say data equals ID num, and then we want key times x for ID num x in order. This problem looks so simple when I read it, and then I tried to code it, kind of tricky. Yeah, I'm kind of annoyed at myself because it is actually fundamentally simple. It's just you have to. It is kind of like indices is one of the first things you learn in Python, so it's like the way I tried to do it was a mess. Moving blocks of memory while linear is still much faster than successive swaps. I guess, yeah. Still surprises me because you could be shifting quite a large amount of memory, whereas okay, whatever. So now we've got the numbers multiplied by the key. So we need to do for count in range 10. Let's just print the count we're on. then we do all this. So for ID num x in order, we get the index. This is unchanged now, because it doesn't matter what. We're using x and not whatever's actually in data. And then so are we doing the same thing as before with the, so it's, yeah, but we're getting whatever's in the data. Oh, so we need that. We need to find 0 again, but it's gonna be, well, it's still gonna be 0. Okay, would that work? But let's try it on the example. So for the example, we want to get 16231 something, all right. One 16231, yeah. 306 at the end. Yeah. All right then. So part 1 is it's doing part 1, and our part 2 it should just be that but 10 times. So it could be a couple of minutes. But yeah. I mean, I feel safer doing these swaps because we're never actually shifting the length of the array. So I'll wait for that to run. Have a look at my leaderboard. So that's you, Quantum, isn't it, Samuel? So did you have a go at 19? 19 took me the longest of coding hours out of all of them so far. 4.5 hours. Yeah, 19 is the one where you actually need to have some custom optimizations to make it work. A textbook algorithm on its own isn't enough. Wrote some code for half an hour and then decided it was a weekend problem. Yeah, it takes a while. Can take a while. I think the top 100 people were within an hour, which is actually quite slow compared to... So the 100th was 57 minutes. Quite slow compared to the other days. Alright, we have an answer. It's negative. Is that fine? Suppose it could be negative, yeah. Could equally be negative or positive. Nope, it's wrong. Damn it. What did I change? This is exactly the same method. So if I'm in range 10, it counts. So when we go back to the new loop, we could go off ID num x in order. Wrong scene emo. Okay, that's good. So it's just this, but doing it 10 times. Hang on. You're operating on... I thought we're supposed to use the alt movements. Oh. We're actually supposed to use the new movements? They didn't actually say that, but I guess there was no reason to... Well, it said the exact wording is, are still moved in the order they appeared in the original. But, okay, fine. Damn it. Alright, so we can't swap. Well, we could. We just have to find where it'll end up and swap towards that, I guess. It's not quite the same as doing insert, because when I'm deleting and inserting, I'm messing everything up somehow. Alright, I'll try this then. I'll try dealing with this, So how on earth did I get the right answer for the example? Was it just coincidence? Can't have been coincidence. We're adding 3 things together. I don't know. Okay, so ID num x in order. So we find the thing which needs to be moved. The, let's say, target I equals data I1 plus I %n. So no having to account for whether it ends up on the left or right of items and stuff. So that's the target position we want to move it to. So the amount of shift would be well, yeah, that's fine, isn't it? So the shift would be the target I minus I. So if it's like to the left of us, be negative. And then we do this for in range shift. Okay, would that work? Let's try with the example. I don't understand why it worked on the example. That doesn't make any sense to me. So we get 3, and now we get 2, 4, 3, 4. So now we get the wrong answer for the example. 2, 4. 2, 4, 3, 4 is one of the items. Alright, let's print the arrays then. I don't know. Print. So after the first swap, we should end up with, after one round of mixing, we should end up with, okay, that is completely different. No, wait, okay, let's see if we can, 0, 2, 4, yeah, it's wrong, it's different. Ah, for goodness sake. Well, it's probably something small then. So let's see, ID num in order, for I in range n, data I 0 equals ID num break, okay. Now the target I will be, okay, maybe target I is just wrong. Target I, so it'll be the current I plus that number as a movement. %n. Doesn't matter if we go left or right. It shouldn't. No. The mod n-1 coming in again. But if we're not doing deletes or inserts, I thought that eliminates that concern, because it's always our n items represent the n different positions. Right, let's print I take a list of 3 items. 1, 2, 3. If 2 moves 3, you'd say it moves. So 2 is at position 1, index 1. So I'd say it moves 1 plus. Moves to 1 plus 3, 4. 4 mod 3 is 1. Okay, so yeah, my calculation would say it stays still. But you actually move it 3. It actually moves 1 to the right. Huh. Yeah. Yeah, I see what you mean. The shift amount. Wait, so this target II, this should be n-1 here. Well, no, the target should be using n. Shift. I think the shift is write something. Try changing this to n-1. I don't fully in my head understand this stuff. 162, 162, and that's correct. Yeah. I don't 100% understand why we need that. I guess I'll have to go over it afterwards. We can try this then. It's so confusing. If you take an element out of a list, the list is one shorter. Then you calculate the insert index. But I'm not taking anything out of a list. It can only move past n-1 other elements. Okay. That, when you phrase it like that, that makes sense. Yes, okay. So I shouldn't be thinking of target location. I should be thinking of how many things am I swapping with. That's what the movement means. So it's like and every time we do n-1 swaps, that just cancels out. So the number of swaps would be okay. So I shouldn't be thinking about this target I at all, really. I should be saying number of swaps. Only if you think it out, take it out first. If you just move the values, you have to use n-1. Now that I'm going with this swaps only approach, because when I was taking stuff out, I was messing everything up. What it should really be is this is the movement. So swaps. It'll be that percent n-1. That's the number of swaps to do. And it could be negative, meaning I'm doing swaps backwards. And then each swap, we are going one to the right and one to the left and doing the swap. Does that make more sense? Hang on. Let me do the example again. Yeah, so that's still the right answers. Okay, that conceptually, that makes far more sense to me now. If I'm thinking in terms of swaps, the swaps, yeah, every n-1 swaps is back to where you started. And now for each swap, we do it independently. We take the thing that's next door to it, swap. Alright, this looks better. Man, this problem shouldn't have been hard. If I had done it maybe using a linked list or something, maybe no, that would have been hard as well because... No, a linked list, but we are using a list as a linked list. That's essentially what we're trying to do. Maybe a linked list would have helped because then I would have stopped thinking about indices. And think only about relative positions. I need to print. Okay. Alright, run it. Four, 5, 7, 8 was correct for part 1, but we haven't changed part 1's stuff. I shouldn't really print this. Whatever, just wait then. Yeah, I think fundamentally the one mistake which I was carrying forward throughout this entire ordeal was that thing with n-1. And even though you did mention it to me a couple of times, Quantum, I think it only really registered in my brain right now. Based on the AOC stats, this task is holding up quite a lot of people. Yeah, it's not, I mean, coding-wise, it's definitely straightforward. It's just something... Now that I've done it, I don't think I'll run into this problem again. I will think carefully about what it means to swap in a circular list. But that just means it's a good problem, yeah. Yeah, that's correct. Yeah, I mean, I could definitely see it. So I'm guessing the top 100 was still very fast, because it is a very quick program to code. And if I had just done that swaps thing from the beginning, I would have been fine within like 25 minutes or something. Top 100 is actually not that fast, really? Oh wow. Yeah. 21 minutes. I feel like I could have placed, if I had just done the swaps approach from the beginning, and not fall into the trap, but therein lies the catch. Wow. I'm surprised. Like, I would have thought a lot of the competitive coders would have known that trap, known how to deal with circular lists. Circular lists is actually a popular puzzle problem. It does come up in all these sites, HackRank and stuff. So, I'm surprised they took that long. I suppose it takes a while to run, at least the way I've done it. I could have done it using inserts and deletes, but... what was my rank? Yeah, that is surprisingly high for something that took me 2 hours. Wow, okay. Yeah, that's overall just really surprises me. The wording of the problem is simple. It's all down to whether you understand a movement in a circular list. I'm surprised so many people... I feel like when I was beginning to learn Python, I had just finished my maths degree and I was beginning to learn Python. I think I would have done better then. I wouldn't have had my head filled up with so much garbage with all the stuff that I've learned in the meantime. It would have just been back to the mathematical principles. I reckon I would have placed like top 100 if you roll back 10 years and I was just learning Python. But just coming from my mathematical understanding. I mean, back then I was better at competitive coding despite not having coded. I did get a t-shirt in the code jam. And since then, I've never been able to win a t-shirt since. The Google Code Jam. I think I placed in the top 1,000 or something. And since then, I've done the Code Jam pretty much every year, and I can't repeat that performance. It's because we become proper programmers, and proper programmers don't do this crap. Proper programmers just write clean code that's easy to review, has test cases, readable, everything which this code doesn't satisfy, basically. Yeah. All right. Well, I can now treat myself to lunch. I'm pretty disappointed with my performance with that. Even though I fell into the trap early, I should have recovered. I should have done a small example on paper and realized what I was doing wrong, but I didn't. It took me forever to realize, so... Alright, well, thanks for the advice, Quantum, because that helped a lot. I would have been stuck here longer otherwise, probably. And, thanks, stopping by, Shobi Jesus, and, a divorced fork as well. I guess technically I did finish this one faster than yesterday, so I'll have more free time today. Basically, this Christmas holiday period is just full-time job for me, solving these. I'll see you tomorrow. Hopefully I'll be on time for the next problem. Alright. Bye. Funny that I topped... Yeah, that one was just hard. Part 1 was, on its own, very hard.